Hi, boys and girls. Welcome to Chapter 8, Lesson 4. And before we start, somebody's been bothering me today to get in here to the video, and it is the math cat, Frank. So he wanted to say hi to everybody. Can you say hi, Frank, before I send you out? Say hi, buddy. Can you say hi? Oh, he's not going to say hi now. Say hi, hon. He really wanted to get in here. Okay, let me get rid of Frank, and then we'll get started with Lesson 4. Goodbye, buddy. He's probably going to be whining at the door. You might hear him in the background. All right, today, Lesson 4, Chapter 8, Lesson 4 is called Multiple Representations of Functions. This chapter really ties things together. We're going to look at all the ways that you can think of a function. It can be a story, it can be words, it could be in a table, it could be an equation, it could be in a graph. And you should be able to move back and forth between all four of those representations. So let's get started with the first representation, and that is a function can be a situation or story written in words. And the situation that I'm going to talk about, I've seen these about around town a lot lately, Girl Scout cookies. Many of you even sell Girl Scout cookies. So the situation, words or a situation. Or also you could think of it as like a story. Here's the situation with Girl Scout cookies. They're $5 a box, so the total money that you earn, total money earned equals $5 times the number of boxes sold. All right, so there is words that could also describe a function. There's a function in these words here. Total money earned equals $5 times the number of boxes sold for Girl Scout cookies. So that is the first representation, is words or a situation or a story. Okay, the next thing we're going to look at is variables. In this situation, there are variables. Now, in your practice problems, sometimes it gives you the variables. It'll say, let B equal the number of boxes sold and T equal the total. But not always does it give you the variables to use. So sometimes they're given, it'll tell you use this variable for this. Other times it might just be like that, where you've got to pull out the variables and make them up. So when I look at this situation, there's two things that are changing. The number of boxes that you could sell and your total. Those are both going to be changing amounts. I'm going to make up the variables B for number of boxes of cookies sold, but I might have said C for number of cookies. And for total, I'm gonna put the T for total, but I could have used M for money. I could have used, again, the variables, unless it gives you the variable to use, you're free to use whatever letter, assign whatever letter you want, as long as you're defining it. Here's what that means. So I'm going to define the variable B equals the number of boxes sold, number of cookie boxes sold, and my other variable is I'm going to assign T. That is the total money. Total money that you've earned. All right, so that's another representation of a function, is using variables. And let's change colors. Okay, next representation is a table. A lot of times kids get stuck on these kind of problems, representations of functions and working with functions. A big tip is make up a table. Okay, think about what's changing, what's happening, make a table. And what value should you use? Well, start with the value of 0, 1, 2, 3. Start easy. Start with 0 and then use the values of 1, 2, 3 and see what happens. Here's an example. Now let me walk through an example of that. So there's two variables, and think back to the very first lesson. There's an independent variable and a dependent variable. And the independent variable corresponds to the x value, and the dependent variable corresponds to the y value in a function table. And the independent variable, if you're trying to figure out which variable is which between these two, one of these is the independent and one is the dependent. So a couple of tips. The independent variable usually comes first. So what happens? Do you have a total first, or do you sell boxes first? Well, first you got to sell some boxes of cookies, and then you get the total. So this is going to be our independent variable. Another way to think about which out of your two variables is the dependent or independent is one variable depends on the other. That's the dependent variable. The total, and so in this situation, the total amount of money that you collect depends on how many boxes you've sold. So that makes this the dependent variable. Okay? So again, two things about the variable. The independent variable usually comes first, and the dependent variable depends on the independent variable. So now let's go ahead and make our table. We've got our independent variable, independent variable. I'm just going to abbreviate V. And we've got our dependent variable. And again, the independent variable corresponds to the x value. The dependent variable corresponds to the y value in ordered pairs. And also the independent, I'll just put, usually occurs first as a reminder. So this is where kids get hung up a lot, and you've got to just go make up a table. Put in the numbers. Here's where I'm going to go put in 0, 1, 2, and 3 and figure out, well, how much money do I have? So if you sell 0 boxes of cookies, that one's pretty easy. If you sell 0 boxes of cookies, that's the boxes sold. How much money am I going to have? I'm going to have 0 money. What if I sell 1 box of cookies? How much money are we going to have? $5. What if I sell 2 boxes of cookies? $10. 3 boxes of cookies? $15. So now we've got a function table. And from this, over here, I'm going to put the ordered pairs. Remember, from a function table, you can graph this, and the ordered pairs would be 0, 0, 1, 5. I'm just doing x and y, 2, 10, and 3, 15. And of course, this continues. Okay, so words, variables, table. Table is a big one. You're going to hear me a lot that's going to say, make a table, make a table. Here's a table for our Girl Scout cookie situation right here. This function table comes right from this, and these are our variables. Okay, next, an equation. Before I talk about an equation, I'm going to give you our hidden treasure vocabulary word for this lesson, and that vocabulary word is reciprocal. So I'll spell it. You can write this down at the bottom of your note page. reciprocal. And again, it's pronounced reciprocal. We learned what a reciprocal was a few chapters back. So look it up. You can use your glossary, old notes. You can Google it. Figure out what a reciprocal is. And if you can share that, you can win hidden treasure. Okay, the next representation of a function after a table is make an equation that represents your function. Now, remember earlier this chapter, we learned that an equation has to have something equal to something else. It's got to have something on both sides. So if you're asked to write an equation, it better have something equal to something. Otherwise, you know it's not right already. So an equation also has a rule to it. So if this is our independent variable, the number of boxes sold, so I'm going to put a B right here because we used B for this one, and this was the T, the total. Okay, those were our variables in this situation. What's the rule here? What's our equation? What if we sold 6 boxes of cookies? What if we sold 6 boxes of cookies? What's our total going to be? What's the rule that gets us our total? Well, if we sell 6 boxes of cookies times 5, that's going to give us our total. So our total would be 30. When you're coming up with the equation, the total, the y value usually is by itself on one side. So if I look at the y value or the dependent variable in this scenario is t. So I'm going to put t right here, and then I'm going to think, how do I get the total? I could also go back to the words. Total earned equals $5 times the number of boxes sold. And I can just translate this. There's our total. Equals 5 times the number of boxes sold. Well, how do I write that in math? 5 times the number of boxes sold. Right there. T equals 5 times B. There's an equation. Something equal to something. And I can figure out the total for any number of boxes. What if we sold 11 boxes of cookies? I would put an 11 right there. 5 times 11, our total would be 55. So the value, if I sold 11 boxes, this would be 55. Now, the most common way you're going to see 5 times B is not written like that. Okay? Or the most common way that you would see this represented would be T equals 5B. Just going to put the number right next to the variable, and that means they're being multiplied. So these two are, that equation is the exact same thing as that one. This is the more common way you're going to see it written. T equals 5B. All right, so equation is another way to represent a function. We've got one more, and it involves these, the ordered pairs. What do we do with ordered pairs? We graph them. So that is the last representation, is that you can make a graph of your function. So a graph so if we were to graph this function right here, make a graph as neat as I can here, and the independent variable goes on the bottom. So this goes on the bottom, which is the number of boxes. So I'm going to write boxes down here. And tilt this camera a little tiny bit. So we've got boxes, and then 0, 1, 2, 3, 4. 1 box, 2 box, 3, and 4. Independent variable goes on the x-axis because it's the x value. The y-axis, the dependent variable, goes there. So what do I want to count by? I'm looking at my ordered pairs. Looks like 5 is a good way to count. 5, 10, 15. So 5, 10, 15, 20. Remember, our intervals have to be counting by the same thing. Here they're counting by 5s. Here they're counting by 1s. Next, all I do is graph the ordered pairs. Let me get a different color for that. 0, 0, that's going to go right here. 1, 5, over 1, up 5. 2 boxes of cookies is 10, so it's here and right there. 3 boxes of cookies is $15, so $3.15. And it's not on here, but if I sold 4 boxes of cookies, I'd have 20 bucks, so it would be right there. And hopefully you recognize already that that is a linear function. When I connect those dots, I am going to get a line. Okay, linear function, which was mentioned in an earlier lesson. So that wraps up lesson 4, and we've got all our representations. We can have words, variables that represent our function, a table, equation, and a graph. And you should be able to move back and forth through all these. If I gave you a graph, you'd be pulling out the points on the graph to make a table. 1, 5 is that dot. This dot is 2, 10, 3, 15, 4, 20. And you could figure out what the variables are. Oops, I noticed I didn't write in the variable over here. What's this? If this is number of boxes, what's this? Is the total money. And let's label, that's our x-axis, this is the y-axis. So yeah, whatever representation you are given, any one of these, graph, equation, table, words, you should be able to construct the other representations from whatever you're given. All right, that does it for lesson 4. I will see you very soon for lesson 5.